So I'm Andrea Burbank, as he said. I'm going to chat a bit today about building a culture of experimentation at Pinterest. That's not the next slide. I can make it be the next slide. OK. Still not the next slide. OK. So when we're data scientists, and when we come to a problem, we tend to think of it as tackling it with math and tackling it with computers. We came to be data scientists because we were good with computers and we learned to do data, or we were good with data, we were statisticians and we learned to do code. And so when we tackle a problem, we tend to come up from those angles. But what I'm going to argue today, and what we've heard a lot in themes throughout today, is that it's the human part that really matters. And I think the same is true here. So if you've heard of the organizational maturity model for software, it looks something like this. So if you don't have source control, you should use source control. If you don't have unit tests, you should write unit tests, and so on. And all of these are solving the sorts of problems that humans might make and helping to fix them. So what I'd like to propose is an experimentation maturity model. These are really not my slides. OK, well, this is last week's version. I will improvise. So what I learned from doing an experimentation maturity, growing our experiments at Pinterest, was that at each stage, it felt like we're doing great. We've built up our experimentation. We're on a successful track. And so what I'm going to talk about is this whole maturity model. But at every stage, it felt like we could have stopped here. So we could have stopped here, or here, or here, or here. And in the end, this is this whole stage. And now we're at the top. And at the end, I'm going to ask you what the next stage looks like, because I think the whole model is still evolving. So the first stage is getting started, then getting big, getting better, getting out, and getting tools. Let's jump in. Stage 1 is getting started. And oh, darn it, all my slides are gone. OK, well, the problem we're solving here is that people are making the wrong decisions. So for example, at Pinterest, when I joined, we launched a new model of category feeds, and we wanted to see how it was doing. It turned out we launched it the same day as the Olympics. And so all of our metrics went down, and we said, gee, we have no idea whether it's our fault or just everyone was watching TV. And so what I did was I built an experiment framework. As you all know, what an experiment framework does is it takes the whole population, it segments it. In the control, people get the treatment, or in the control, people get the default behavior. In the enabled group, people get the treatment. You can measure the difference, and therefore you can establish causality. So I built this framework. It was really awesome. It did all the things I thought it should do. It triggered users when they were actually affected. It measured the novelty effect. It could work for offline experiments as well as online. It did all the awesome stuff, and I was like, this is great. I'm done. And when you get to this point, it turns out you're not done. That's only the end of stage 1. Because what's really important is that having an experiment framework does absolutely nothing. It's people that run experiments on your framework that will actually make a difference. And so that's why stage 2 is getting big. And the problem you're solving here is that people are not using this awesome framework you've built. So you're trying to solve the problem of having a tool that no one's using and actually get big, get adoption within your company. If you've seen the movie League of Their Own, you've heard this phrase, if you build it, they will come. I think all of us know this is not quite true, but as engineers, we're really, really tempted to believe it anyway. If you build a good enough tool, people are going to want to use it. My experiment framework was awesome. And why were people not coming to adopt it? The thing is, this is a myth, as I was saying. No matter how good the tool, people aren't just going to magically adopt it. You need to sell it to them. You need to do marketing. You need to do evangelism. You need to, interesting, be a salesperson. Maybe that's coming here. Oh, no, it's gone. OK, well, sorry. The key of this phase is trying to convince people to actually use your framework. You have to convince them running an experiment will be easy. You have to convince them, hey, you can do it with my help, and it'll help you achieve the thing you're trying to achieve. At Pinterest, one of our values is go, which means you want to move really quickly. But my job was to convince people they needed to move really quickly in the right direction, and that experiments would help them achieve that. And so if you do this enough times, if you find strategic initiatives that you can prove actually had an impact or avert disaster for your company by measuring things that were going to ruin things and you wouldn't have known without an experiment, people start understanding the value of experimentations, and they start wanting to run experiments themselves. And they start doing it again and again and again. And when that happens, you reach the end of stage 2. You've gotten big. But it turns out that introduces new problems. When you were running all the experiments yourself, And even in the next stage where you were running around trying to tell people, you should run an experiment, and you should run an experiment, and you should run an experiment, you were always there to make sure they could set everything up correctly. You would help explain what they would get out of the experiment. You could explain what they would learn. You could make sure things were going smoothly. Once you've actually crossed the bridge to where your framework has its own momentum and your culture has its own momentum, that's not the case anymore. You're not already involved in every single experiment, and so what you have to do is help nudge people to get better at every stage. What does that look like? What it looks like is you are the human in the loop. So people want to test something, and you're there to help make sure it's successful. You're just giving them the little nudge of like, hey, did you think about whether your hypothesis was actually measurable? Or, hey, did you think about if this will affect 1 million people a day or 100 people a day? Helping them out at every stage. This is actually super duper fun, and this is the stage where I thought I might stay there forever, because you're involved in every decision at the company. You know that the search team is working on this piece of relevance, and you know that the home feed team is trying to figure out how to do recommendations, and you get to play a part in all of these decisions that are shaping your company. The problem is, it's not just one loop. As your company grows, there's more and more and more loops. And in each one, you're trying to ensure success, and your company is learning a ton, and you're having all this fun getting to influence decisions across the whole company, but you're also a single point of failure. And I think this point really came home to me when I was biking in Napa on my anniversary, trying to review code reviews in GitHub, because if I wasn't there looking at experiments, they would go wrong, and people would make the wrong decisions, and they would be set up incorrectly, and so on. And I think how quickly you get to this stage and whether you think you need to exit this stage may depend in part on how quickly your company is growing. And Pinterest grew really, really quickly. So I joined when it was about 50 people, and now we're about 700. So I think the end of this stage came particularly precipitously for me. But I think the important thing here is that it's true even if your company isn't growing. If your company is growing, things are going to go crazy. Things are going to spin out of control. But if it's just staying the same and you're doing fine, you're helping everyone run experiments, yes, you're helping people run experiments, and it's beneficial to the company, but what else could you be doing? It's not your career goal to be the experiments person. You should have higher ambitions. What are you missing out on if you're just helping people do the day-to-day of running experiments? And so at Pinterest, once I'd made that realization, that marked the end of stage 3. So stage 3 is all about helping ensure people are successful, that they've adopted their framework, they're running experiments, and you're nudging them in the right direction to make sure they know what they're doing so that they actually learn things. But at the end, when you're trying to bike and you're trying to do code reviews and everything is going wrong and you're running around, that's when you need to move on to stage 4. And that's what I'm calling get out. It's not that you get out completely, but at this point, the problem is you're the single point of failure for the organization. And what you really need to do is scale yourself. And the question here is, how do you do that? How do you go from being the person who knows everything about experiments and the person who gets to know everything that's going on at the whole company to turning that into a self-fulfilling culture? The first step is to write down the process. So what are the mistakes that you see happening in experiments? What are the questions you're answering over and over and over? And lastly, people respond to incentives. What's in it for them for taking over your job? Let's look at those one at a time. I wrote out every single thing that was going wrong with experiments at Pinterest. I dug up this list recently. This is slide 1, and this is slide 2, and the font size is really small, and you can't tell what's going on. And this is slide 3. And the point of that is not that you should be able to read all those, although I will post my slides later, but that when you run experiments, if you let engineers run experiments, they will screw them up in every way possible, in the words of my colleague. I would rephrase that slightly as if you let untrained engineers run experiments, they'll screw them up in every way possible. So what's the correct way? What's a way that you can use to train them to try to avoid all these different screw-ups? If you haven't read Atul Gawande's The Checklist Manifesto, I highly recommend it as a book. He talks about how you can take incredibly complex problems like building a skyscraper or flying an airplane or performing surgery and still improve the outcomes with incredibly simple checklists. It turns out that when there's a million things you're trying to keep track of, having a checklist that says step 1, keep flying the airplane, is actually very, very valuable. And so we took this at Pinterest and we implemented it. The other thing is knowing when checklists will be useful. So what we thought about is where can experiments go wrong? When you're building the checklist for every mistake, explain what's wrong and how to avoid it. The important thing is where can experiments go wrong? And what we learned were there were sort of 3 big phases in the life cycle of an experiment. So the first is launch. When you're about to take off, what are the different things that you need to check to make sure all your systems are working correctly? And I touched on some of these earlier, but it's things like, are you trying to change the right thing? Can you measure that thing? How will you know if you've changed it? How will you know if what you're doing is actually wrong? Is the thing you're doing a good idea in the first place? Once the plane has taken off in our little analogy, or once the experiment is out to real users, sometimes things will come up where you want to change things. It could be that you had a new brilliant idea and you want to introduce a new variant. It could be that while you're measuring it on 1% of the population, you want to increase your statistical power. It's another phase where things can go wrong. And then lastly, when you're done with your experiment, it comes time to decide what to do with it, and you can decide to do the wrong thing. So those are the 3 important phases where we implemented checklists. Just a note, this is small. The goal is not for you to read it. I'll post it later. But this is our actual experiment doc. And what it says is it just asks those questions I just posed to you. Is your hypothesis measurable? Did you write it down somewhere? Is the place you wrote it down somewhere that I can find? Is it somewhere that we'll be able to find even if you leave the company? Are the hypotheses clear? Like, it is not rocket science, and yet things on this list go wrong basically every single time. Does the doc support the hypothesis? So if you say, I'm going to add a button that lets you follow people, is one of your hypotheses that follows will increase? Or are you like, people are going to visit Pinterest all the time and it's going to be awesome? You'd be surprised. So a lot of questions like this. And one thing you'll notice about these questions is they're mostly about thinking. They're not things that computers can solve. They're things about, are you thinking about this the right way? Is the problem you're solving important? Is the thing you're proposing likely to solve that problem? And that's why when I talk about a culture of experimentation, it's really about building the people and the thoughts around all these things. So the next phase, as I discussed, is in-flight. Lots of things can go wrong in flight. The main thing people want to do is say, hey, my experiment's looking great. I want to roll it out to more people. Turns out they don't often do the phase 1 of it's looking great. They just do the I want to roll it out to more people. So the checklist says things like, is it currently out to the number of people we expected? Does it seem to be doing the thing we expected? Does it seem to not be hurting our users? Again, very simple things, but things that can go wrong very easily. And lastly, once an experiment is being shut down, we have a checklist to make sure things don't go wrong. One thing that happens here, people are like, look, I've been running my experiment for 2 days. Things are looking awesome. I think I'm going to ship it. And so we have a checklist to say, well, do you have enough users to actually be sure of your decision? Can you measure the long-term effect, which after 2 days you clearly can't, of your decision? Is the long-term effect likely to be different from the short-term effect? If all those answers are yes and you're ready to ship, are you making the right decision? Is the variant you're picking actually the best variant? Again, very simple things, but things that help people think through all these steps. And again, things that are human, that can't just be done by computers, that are about, are you thinking about the right pieces? So that's all lovely, but all these checklists in the world won't do you any good unless you actually have someone to implement them. And so we thought about, we need 2 things to implement them. One is a low-friction process, and the other is people to actually do it. So in order to implement a process that was relatively low friction, we took our culture of R+ and turned it into E+. That may mean nothing to you. So R+ is basically what we took from Mozilla. It's a code review convention. So when you review the code, you look at it, you decide, hey, do I think this improves the code base? If yes, you say R+. If no, you say please revise. And so we already had a code review process implemented at Pinterest. And what we did was say, hey, if your code change also affects an experiment, please just pull in one of us. We'll take a look. We'll review your experiment setup, and we'll give it an E+. And an E+ says, we've looked at your experiment. We think it seems reasonable. The thing about R+ is it was optional. But in practice, everyone does it. And that's a magic way of introducing quality without introducing friction. The only people who ship code at Pinterest without getting an R+ are new grads and interns. And we wanted to build the same thing for E+. So that's great, but who's actually going to give an E+? We built an @mention type thingamajiggy called Experiments Help. And I think there are 3 important things about building Experiments Help that contributed to its success. The first is actually calling it Experiments Help. When we were batting around this idea, we were like, we'll call it Experiments on Call. But who likes being on call? You get paged in the middle of the night, and it really sucks. But who likes helping people? Like, I like helping people. So calling it Experiments Help gets people to start buying in right away. The second thing we did was make it something where we were partnering with engineers. So I'm on the data science team, and data science can be like the people who are telling you, no, 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 don't do that. And so what we did was we got buy-in from the engineers to say, like, hey, by you training to be an experiment helper, you can help your team move faster, and you will actually own the process. And the third piece is actually related to that, which is getting the right people. So when we picked the first people to be experiment helpers, we picked really thoughtful, well-respected people within the organization who could then take these important questions and the important procedure of doing experiments and take them to their teams. And one thing I actually noticed about this when I was putting together this talk is looking back at that first set of people. The first set of people was people I thought were awesome. The next set of people was like some other people. But it turns out they're awesome too. And in part, you can say, like, I have excellent judgment. But I think also, because we partnered with engineers and made them owners, it helped them become leaders. If you're the person that everyone on your team has to turn to figure out how to run an experiment, you become the leader of that team in certain ways, and I think it helps people grow. So that's what some people call a badge value, but I think that's a third part of the success of our experiment help program. And so once we had those three pieces, we sent out again this small text email just announcing this to the company, saying, here's our new process. What were the pieces of that process? We've talked about them. So we had checklists for experiments. We had a way to mention experiments help in a code review to get help. We had E+ as experiment sign-off for a code review. We created a mailing list so people could ask us questions regardless of whether it was at code review time or other times. And we had a template for the experiment document to say things like, what's your hypothesis, and who are you affecting, and what will it look like? And lastly, we had a rotation of experiment helpers. And as I said, a key piece of that was figuring out who the helpers should be and how to train them. And so you might think, OK, I've just talked to you for 5 minutes about all these checklists. Hand these checklists to people. You're all set. But what we think is that learning by doing is really important. And so we set it up as an apprenticeship. And yeah, the first stage is read the documentation we've set up. But the second stage is put you on the spot and take a quiz. This wasn't fancy. It's just a Google Doc. But it puts into question all the things we've seen going wrong and says, hey, if you had to decide what to do, what would you do? And it turns out that's really powerful for developing people's actual thinking. Like, I still remember the questions I got wrong on the SAT because it was a test, and I had to know, and I had to decide. And then the third step is trial by fire. You are in charge for a week. You have to review all the experiments. What decisions are you going to make? And where are you going to ask for help? Because being an experiment helper doesn't have to mean that you know all the answers. It has to mean you know what you know, and you know what you don't know, and you know where to go when you need help. And so with those pieces in place, it went from just me reviewing experiments to me and John and Dan, and then from me and John and Dan to a bunch of engineers around the whole company. And at this point, we're up to 50 trained experiment helpers at Pinterest out of about 300 engineers total. Some on every product engineering team, and it's built its own self-sustaining culture where I don't have to answer questions anymore. People are just answering each other's questions in the Slack rooms and on email, and people are developing their own experiment culture within individual teams for the things that they need explicitly. And so I think when you get to this point, you've scaled successfully your experiment culture. Instead of saying, how can I help you? You're saying, how can you answer that? And how can you answer that? And then suddenly you're not, involved. And people are asking each other how to answer that. And you've got a whole bunch of people across the entire company who know what experiments are like, who know what the right questions are to ask, and who can push the quality of our experimentations higher and higher. And at this point, again, I was like, this is awesome. I'm done. But it turns out that once you get to step back from this a little bit, there's more you can do. And so what I've talked about is how important all these questions are and how they're all human questions. But it turns out that some of the questions are not human questions. Some of the things that we kept seeing going wrong over and over again, we said, hey, if we improved our tools, we could actually get those to go away so the experiment helpers could focus on just the thinking. And so in stage 5, when you're a little bit stepped back from the day-to-day, you have time to do that. And I think what those tools will differ at your company from my company, but just to give you an idea, I thought I'd walk through what those were. And again, they're aligned to the stages of the experiment life cycle. And they're set to solve simple mistakes so that people can do the thinking and machines can do the not thinking, and then everyone's using their best skills. So tools for launch. This is where a lot of things can go wrong. And as I said, most of the things are thinking, but a few of them aren't. So things like, we used to have about 25 different functions you could call that would either not trigger the experiment, but check which group you were in, or check which groups you were in, or kind of trigger, but only sometimes. And it was just really complicated. So we simplified the API. We removed the idea of untriggered experiments, so just everyone on Pinterest is affected. Well, that's really, in practice, almost never true. Just say where people are affected, and then we'll measure the right set of people. We created helper functions, so you weren't reaching into the internals of our nice little gatekeeper object to figure out what was going on, but we could just say, hey, like, I only want to test the latest version of the iOS app. OK, great. Here's the right set of people. Similarly, there are tools for when you're trying to change things in flight. The two things we saw going wrong the most were people had a great idea for a new variant, and they were just going to add that variant. Well, it turns out that doesn't work out well, because if today is New Year's Day, or people today just happen to be different from yesterday, or you're Pinterest and you have strong day-of-week effects, those groups are not going to be comparable anymore. And so we now automatically add a control group whenever there's a new variant. And secondly, same idea, expand experiment groups at the same rate. So if you have two groups that are 1%, make them two groups at 5%. Don't roll up one and not the other, because then again, you're going to introduce differential due to temporal things and not due to the actual differences between the variants. And the last thing, which we invested in the most, is at the stage where you're landing. So now that we've stepped back from the process, we really want to make sure that people are still making the right decisions. And that has two pieces. One is their data is actually correct, and the other is they're interpreting the data correctly. So in terms of making sure the data is correct, we wanted to make it really easy to detect when things go wrong. We have a chi-squared test on group sizes. If things are red, it means, hey, the allocation of these groups doesn't match with the percentage you allocated. So in this case, the enabled group is much bigger than the control group, even though I allocated 25% to each. Looks like something's going wrong. We test that groups are growing at the same rate over time for the reasons I just discussed. We verify that the distribution of the types of users in each group is the same across the control and enabled group. And we hide results on the dashboard for things we think are wrong. So if we think you're doing the wrong thing, we put up a giant, hideous yellow message, because I'm not a UI person, that says, like, hey, I think you don't want to look at these results, because sometimes our computation is wrong. There's a little button that says, click here to show the results anyway. But it's going to show this warning, and it helps people not shoot themselves in the foot when they didn't mean to. And then if all those things go well and it looks like your experiment is set up correctly, the best way to make sure people do the right analysis is to do it for them. And so we simplified the analysis, so we have a dashboard that automatically tracks all the metrics we think are important, automatically calculates statistical significance. This takes away people running their own SQL queries and doing the wrong thing. Similarly, it lets you segment by important segments of the population. So you can look at what were the results for women in Japan, or what were the results for men who signed up on Facebook, or what were the results for men who signed up on Facebook who are core, who signed up via iPhone and are on Android today, right? So this is dangerous in some ways, which I don't have time to talk about right now, but it really lets you understand if you're shipping something that you think will affect different sets of people differently, you can understand that automatically through the tool. And then you can measure the novelty versus the long-term effect. So this is something that I think is incredibly important, of measuring how something will affect users in the long run. At Pinterest, our value is getting people to keep coming back to Pinterest over time and find value from it over time. We don't want to ship something that's awesome today but turns out to be terrible over the long run. And so we built in automatically measuring the novelty effect so that we can tell what the effects are over the long term. And what those do is those give you tools to avoid the simple mistakes, and they let the humans focus on the thinking. And so that's the experiment maturity model to the point we've gotten it to right now. So you get started by building a framework, you get big by getting people to buy in, you get better by helping them actually run experiments correctly, you go crazy because there's too many experiments and you start to get out and help other people do that, and then you get to step back and build the tools that will help people just focus on the thinking, focus on the hard part. I'm not sure what the next stage looks like. Maybe some of you in the audience have gotten further than I have, and I'd love to hear about that. But I think the themes here apply a lot beyond just experimentation. I think getting people to buy in, getting people to pay attention, getting people to think about the hard things is really what data science is. And it's not just a culture of experimentation. It's a culture of, hey, I built a model. I don't want it to just gather dust on a shelf. I need to change people's minds to get them to use it. I need to change the way people think about data and about experiments and about making decisions in order to make myself powerful. And so that's where I end. Data science, changing minds one at a time. Thanks. And I have no idea what time it is because the clock is also broken, so.
That was so great.
Oh, I'm a little over, sorry.
I think it's totally okay. Can we get to maybe one question? We got time for one question? Okay, if no one has one, I'm totally going to ask it. So how do you guys deal with the issue of like multiple comparisons? You were showing the Japanese women versus the men who signed up through Facebook. How do you handle multiple comparisons?
Yeah, so I guess you guys can hear the question. It's about multiple comparisons. We mostly tell people to think.
Yeah,
so
that's a tough one.
We try to get them to say up front which populations they think it will affect differentially, and make sure they've looked at those populations. And I think there's a standard set of people we'd like you to look at, so US, non-US, women and men. But if you start saying, I'm going to ship because it's up for men in Japan who signed up on Facebook, you better have a really good reason you think it should be up for men in Japan who signed up on Facebook, and not just be saying that. I think we've built things like, we tried to do automatic anomaly detection to say, yes, overall your experiment is up, but it's down in Japan. It turns out we are still rather small in Japan, and so that was mostly a result of noise. But I think we are working on sort of automatically highlighting important populations that you don't have to think about which segments to look at, and you get to look at the segments that are actually important.
Awesome. Andrea, thank you so much. That was absolutely wonderful. Even though I messed up her slides, she did a really good job.